Welcome to my new calculus channel. My name is John Gabriel, and today I'm going to talk to you about the origin of zero and how it came to be. And as you know, most of my videos are impromptu. In fact, all of my videos are impromptu. I record them once and I don't go over if I've made any mistakes. I correct them in the details sections of the video. So, let's talk about the origin of zero. So, there's a brilliant article in the Scientific American. Well, it's not really brilliant, but it's brilliant as far as mainstream thinking goes. The first evidence we have of zero is from the Sumerian culture 5,000 years ago. So, zero supposedly was invented, but well-formed concepts, as you know from my previous videos and articles, are never invented. They're only discovered. Now, why didn't the Greeks use zero? And why is it that the most brilliant people who ever lived and who discovered the perfect concepts of geometry and put together the first textbooks on mathematics, how is it that they didn't think that zero was so important? Well, I have news for you. The Greeks actually did think of zero. So why didn't they use it? Simply because, according to the Greeks, a number is the measure of a magnitude. And, for example, if you write down let's say 1 divided, or 1/2, not 1 divided, 1/2, then we are measuring 1 with halves. Okay, so the denominator measures the numerator. Okay, so a number is the measure of a magnitude. 1 tells us we have 1 unit. 2 tells us we have 2 units, and 2 is measured by the unit, and 1 is measured by the unit, just as this one here is measured by 2 equal portions that add up to a unit. This bottom part in a fraction always adds up to a unit. It adds up to a unit because it's the number of equal divisions of a unit. Okay, so not to belabor the point, but the Greeks didn't use zero because a number is a measure of a magnitude, and zero did not actually measure anything. It doesn't measure anything except itself. Okay, so you can't, for example, put zero at the bottom of any number, and every number takes this form, by the way. There is no number that does not have this form here. Even those so-called natural numbers that you've been taught to memorize in a rote fashion, they're actually fractions. Everything is a ratio or a fraction, and if it's not representable as a ratio, guess what? It's not a number. That's right. So square root of 2 and pi, these are not numbers. These are symbols for incommensurable magnitudes. And no, an incommensurable magnitude is not the same as an irrational number, because a number is the measure of a magnitude, and these here cannot be measured with any other magnitude or the chosen unit, regardless of what the chosen unit is. So, the Greeks decided that they were going to use what they had, and zero wasn't part of it. Now, if you come to think of it, you don't actually need zero at all in mathematics. That's right, you don't even need it to represent numbers. How's that? For example, if you carried a template around with you, something like this, and you wanted to represent 20, well, you would just put a 2 under the tens column, right? And there's no ambiguity there. Yes, you don't have to add another 0, but if you're not carrying a template around and you just write 2 by itself, you're not going to know whether it's 2 or 200 or 2 tenths or 200s, etc. Right? So that is the reason why we use zero. It is very useful, but it's not necessary. It's just very useful. It also has an important use in equations. So, for example, if we're having an expression that is equal to zero, then we can manipulate it as we would a scale. Now, the Greeks didn't use zero, they just used equality. So it's really the same thing as using zero, but without using zero. So, for example, if I had to write 2 is equal to 2, like so, is equal to 2, yes, then I could simply rewrite this whole thing by saying 2 minus 2 is equal to 0. Does that make sense? Okay, so let's go back to this article quickly. And we'll see that there's a lot of misinformation inside here. Obviously, a lot of this is opinion by Robert Kaplan. It's not really fact. And we'll see here that he takes a few more opinions and writes about how zero came into being. And then this is quite interesting here. It says the mathematical zero and the philosophical notion of nothingness are related but are not the same. Nothingness plays a central role very early on in Indian thought. Now, actually, what he doesn't realize there is that the Greeks started with nothingness. If you watch my first video on the topic called "There Are No Axioms or Postulates," you will see that the Greeks derived everything from nothing, starting with the very point. Okay, so this is nonsense here. The mathematical zero and the philosophical notion of nothingness are exactly the same. In fact, guess what? If they weren't, the Greeks wouldn't have written down geometry the way they did. So that's completely wrong. And then he says, but our inability to conceive of such a void, well, maybe his inability, but the ancient Greeks understood a void perfectly, and that's how they discovered geometry, because they started with a void. In other words, absolute nothing. So while zero is very, very useful, and we certainly wouldn't want to get rid of it, it's not important in mathematics. Not important as the very fact that a number is the measure of a magnitude. Zero doesn't really measure anything except itself. Okay, so as I explained to you over here, if you have to write down a number, you can't put zero down here because zero can't be divided into portions which are of equal sizes, and when added will give you 1, okay? Because that's what a fraction means. If you write down P over Q, then Q tells us how many equal parts the unit has been divided into. All right, so zero cannot measure anything but itself. So zero measures itself once, right? But we obviously don't do this also in mathematics because it can have ambiguity, and especially when we use the properties of arithmetic, which also, by the way, were put in place by the ancient Greeks in Book 5 and Proposition 12. If you haven't studied Book 5 and Proposition 12, you need to do so, because you cannot understand the binary operations of arithmetic or why you do the things you do with fractions unless you actually understand that proposition. It covers everything, all the operators, the difference, addition, division, and multiplication of fractions, and consequently every other number, because if a number is not a fraction, if a magnitude cannot be described by a fraction, it is not a number. A number is the measure of a magnitude. So anyhow, I've rambled on a little bit about zero and how that the Greeks knew about it but didn't elect to use it. And they were the smartest people on earth, and still today their brilliance is unmatched. Certainly not by the infinitely many morons who came before me. If you have a look at my discussion on forums, even when I correct these mainstream academics, they're insanely jealous of my new calculus. They've tried several times to take down my site. Recently, I posted a question on LinkedIn where I asked a mathematician, an Indian professor, to answer a question about triple integrals. He got the first one right, but the second one he got wrong. Well, it just goes to show you that a lot of mainstream academics memorize things. They don't really understand them. And before I came along, and after Euclid, not a single academic understood what it means to be a number. So I hope you've enjoyed watching this video and that you will join me again next time for another video. I am the great John Gabriel, discoverer of the first and only rigorous formulation of calculus in human history. Till next time, goodbye.